Hey guys, welcome to Chapter 11, Thinking and Thought. This is our final video of Unit 4 before your test on Thursday. So let's get started. So the definition of thinking, we're going to get a little philosophical in this chapter. We're going to think about thinking, if that makes sense. So the definition of thinking is changing and reorganizing the information stored in your memory to create new information. So, if we think about how we go throughout our day, we kind of reason through our day, like, okay, this road's blocked off, so I need to take a new road, or, I need to do this before I do this. I have to put my clothes in the washing machine before they can go in the dryer. They have to be dry before I can fold them. We're basically organizing the information that we know has to happen. That's the simple definition of thinking. Okay, so we think in units, we think in chunks. We don't think in these huge ideas. Our brains are trained to break things down into manageable pieces. So, two of the ways that we have units of thinking are images and symbols. So, we know what an image is. You take a picture of something, you have an image. It is a visual representation of an event or a object. So if I were to show you a drawing that looked like this, most of you would know what this is. It's a house. So that is a visual representation of an object. The house is the object. Our brain is trained to think of things in the simplest way. And then a symbol. Symbols are a little bit more, this is the philosophical part. Symbols are a little bit more indirect. So they're an abstract unit. Abstract means it's not concrete. It's kind of loose. It's free forming. An abstract unit of thought that represents an object or a quality. So a symbol could be something like the biohazard symbol that you see on like medical supplies. So that biohazard symbol lets you know that this could potentially be dangerous. If you see this symbol, this one right, this one right here. This is an exclamation point. This symbol usually means that something is important or something is being emphasized. So that's a symbol. It's more abstract. So the house is representing simply a house. The symbol of the exclamation point is saying that this is important. This is more emphasized, but it doesn't say the word emphasis. It doesn't say the word loud. It's just a symbol of what it means. And then more units of thought, concepts and prototypes. So a concept is when you try to make a file folder for something. So grouping similar objects, events, ideas, or people. So we have the concepts of male and female. We have the concepts of people who fit the category traditionally of male and traditionally of female. We have the concept of animals versus people. We know animals usually either walk on four legs, have fur, have a tail, slither maybe. Not a big snake fan, but slither. And then we know humans walk on two legs, speak a language that is generally recognizable by everyone else in the world. There are all kinds of things that distinguish humans from animals. So those are concepts, characteristics that make things seem similar. And then a prototype, the mental image or best example of a category. Okay, this is easy to overthink. But when I ask you to picture a bird, without thinking about it, a lot of you probably pictured a red bird. But I never told you to picture a red bird. But a cardinal is such a common image that it's become our prototype for the word bird. So if I were to ask you to think of a fence, without me giving you any prompting, you probably thought of either a chain link fence or a white picket fence. I didn't tell you what type of fence to think of, but that's the first thing that your brain went to. Hopefully that makes sense. If you need more examples, we'll talk about it on the Zoom call. But that's a concept versus a prototype. And then we have different types of thinking. So we think in convergent and divergent ways. And this This gets a little confusing, but we do this all the time. It's really just learning the names of the processes. So in convergent thinking, this is where you look at all the possibilities that are laid out in front of you and you think about all of the possibilities and determine the single best solution. When you're taking a multiple choice test, you read the question, hopefully, first, and then you read all of the answer choices and you mentally go, okay, I know it can't be A because that's just completely wrong. I know it can't be D, that one's completely wrong. So it's either C or B. And then you read C and B over and over again. And finally, you decide maybe B is the one that sounds the best. So you've narrowed down from 4 solutions to 2 solutions to 1 solution. That's an example of convergent thinking. You do this when you pick your clothes out in the morning. So you open your closet, you have all of your clothes. You have winter stuff, you have summer stuff, you have in-between stuff, you have jeans, you have t-shirts, long sleeve shirts, hoodies, whatever. So you start to think, okay, it's going to be warm today, so I can probably X out the hoodies, I can probably X out the jeans. So you're left with maybe t-shirts, capris, and shorts. Well, it's not quite warm enough for shorts, so maybe I'll go with the capris and a t-shirt. That's convergent thinking. You started with all of these options and you slowly narrowed down to the solutions until you got to something that made sense. Divergent thinking. This is the exact opposite. This is where you start small and go big. You expand the number of possible solutions. So this is where you're like, okay, I have a problem. I broke my mom's vase. Okay, my mom is going to be home very soon. I can either A, clean up the mess and hope she doesn't find it, B, try to fix the vase, C, replace the vase, or D, just tell her I broke the vase. So this is where you start with a problem and you open up and try to think of new solutions. This is where your creativity comes in. So this is the opposite of convergent thinking. You're not trying to narrow down possible solutions. You're trying to open up and expand and think of any possible solution you can think of. So that's convergent versus divergent. And then metacognition, this is one of your vocabulary terms. Metacognition is thinking about thinking. That's about the most simple way that I can think of to put it. So right now, while you're watching this video, while you're either taking notes or just trying to understand what the heck I'm talking about, you're participating in metacognition. You're thinking about how your brain thinks. Okay? Problem solving. As humans, one of our biggest challenges in life is to confront the problems that we have every day and try to find out the best solutions. So one of the ways we do this is by algorithm. Algorithm sounds really complicated, but if you think about it, algorithm kind of sounds like the word algebra. And in algebra, you have various formulas and hypotheses that get you to the different answers. So in algorithm problem solving, we're taking a methodical rule or a procedure and we're doing it the exact same way every time. This is applying the quadratic formula. This is standard form formula. This is taking a very methodical way of problem solving and doing it every single time and getting the same result. That's an algorithm. In math, if you do 1 plus 1, that is an algorithm. Every single time you do 1 plus 1, you're going to get 2. Every single time you do 10 times 10, you're going to get 100. There's no way to get a different answer in the algorithm method. So in the algorithm method, the cause equals the effect every single time without fail. This takes more time for our brain to process. So our brain has to come up with this rule, has to come up with this algorithm to solve a problem. You have to remember that algorithm and then know the situations where you can apply it. So algorithms typically take up more time, more space in our brains. Heuristics, which is what we're going to talk about next, is the other method of problem solving that we use. Let me use this. So in heuristics, we are basically taking rules that we know about the way the world works or about the way that language works or about the ways that gravity works maybe, and we're kind of eliminating the ridiculous answers. So it's a simplified thinking strategy. So instead of taking this whole algorithm and laying out all the possibilities in our head, heuristic says, let's get rid of the things that we know will never make sense. So this would be like saying, okay, 1 plus 1. Is there any way 1 plus 1 could equal bricks? No, there's no way 1 plus 1 could equal brick. That's improbable. But in the algorithm method, you go through every possible answer to try to get to the answer. In the heuristic method of thinking, you simplify things. You know it's impossible for 1 plus 1 to be anything other than a number. You're not going to get a letter from 1 plus 1. So 1 plus 1 must be 2. You narrow down your possibilities and you think about your thinking. Other ways that we talk about heuristics are rules of thumb and common sense. Let's look at some examples. So in this word right here, I ask you to unscramble it. I'm going to give you about 5 seconds to go through and see if you can figure out what this word is saying. Most of you have probably gotten it by this point. So the word is psychology. And the way that we know this is because we look at the combination of letters and we think, okay, how many words have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters? So we've got 10 letters here. How many possible combinations can we make with that? In the algorithm method, if we were to maybe start with the S and go, okay, so Sployochyg. That doesn't make a word I can think of. Let's try Sployochy. And then you would go through and just change one letter every single time. The algorithm method, it would take you 907,208 tries to come up with the word psychology. There's not many of us that would sit there and change one letter to see if we can make a word. We use the heuristic method more often. So we know that there aren't any words in English that start with YY. We know that usually CH goes together, GY goes together, LOGY means logy, which is the study of. We're in psychology class right now, so you might be thinking in psychological terms, so you're probably looking for the PSY. So you throw out all of those combinations that you know can't make sense. There's not a whole lot of words that start with YS, so you know you can throw that out. You just think about simple terms and simple ways that you can group together those words to unscramble the word psychology. That's algorithm versus heuristics. So sometimes we run into problems when we are trying to problem solve. So one of them is our mental set. When we grow up and as we get exposed and experience new things, we develop mental sets. So we think of things in concrete rules. We think that things can only be done a certain way, or you can only fold a shirt one way. You can only fold a towel one way. So how many of you, when you fold a t-shirt, you fold the arms in first and then lay it down and fold it over? That's one way. Some of you might fold the shirt in half, fold the sleeves in, and then fold it in half again. Some of you may just fold it in half and fold it in half again and call it a day. Some of you probably just cram it into your dresser drawers, and that's fine too, I guess. Some of you also probably hang your t-shirts. So that is your mental set for how to fold a t-shirt. And if somebody folds a t-shirt differently than you do, it kind of, you're like, oh, okay, that's weird. We think of the way other people do things is weird. Example, the way you hold a pencil. I have one of you in one of my psychology class that holds a pencil like this. I have one of you that holds a pencil like this. I personally hold a pencil like this. That's my mental set for holding a pencil. I think of this as normal. When I see something like this, or like this, or like this, or even left-handed, I don't think of it as normal. Your mental set is what you see as normal. And sometimes that can be an obstacle because some problems require us to step outside of what we're comfortable with and try to kind of think outside the box. That one got cut off almost. Another problem with problem solving is the concept of functional fixedness. This is where you think an object only has one function. So if you think that your phone can only be used to talk on the phone and to text, that is functional fixedness. I see y'all doing this all the time in class, especially my female friends. I see you in the back of the class doing your mascara with your phone because you're using your camera as a mirror. That violates the concept of functional fixedness. You're not using your phone to talk on or to text on, you're using it as a mirror. Using a paperclip to reset the Wi-Fi box. So your Wi-Fi box usually has a super, super tiny little button that your finger can't really press, but you can take either the tip of a pen or the tip of a paperclip and you can press that button and reset the box. The pen and the paperclip are not intended to be used to reset your Wi-Fi box. The pen is intended to write things down. Paperclip is intended to hold things together. If you think that the only method or the only way that a paperclip can be used is to hold papers together, you're participating in functional fixedness. And this is why DIY people are so popular, those life hack people, because they take everyday objects and they violate functional fixedness and teach you how to use them in different ways. Using your binder as a plate. Some of you, this is the only reason you use your textbooks is as a plate. So if you use your textbook for the purpose of reading it, or you use your binder for the purpose of storing things, you're doing its function. But if you use your binder as a plate for your sandwich or your waffle or your whatever, you are violating functional fixedness and using it for something that it wasn't created to be used for. So we do all kinds of different examples of this. Using a paperclip I'm on paperclips for some reason, but using a paperclip to fix a broken zipper violates functional fixedness. So if we were to think of objects as only being used for what they were created for, we would miss out on so many different life hacks. Okay, so we have a matchstick problem. So we're given the scenario of 6 matchsticks. And our job is to form 4 equilateral triangles. So I want you to pause the video right here, and I want you to take 6 straight equal-sized objects and try to form 4 equilateral triangles, and I will check back in with you in a couple of minutes. I want to see if you can get the answer. Okay, so hopefully you've had a little bit of time to play with that problem and see what you can come up with. So I tried to solve the problem using a 2D whiteboard, which does not work out very well. So the first time I tried the conventional way to make the 4 equilateral triangles. So I just drew 4 equilateral triangles. The problem was I used 12 straight lines. I was only allowed 6 lines from the problem. So then I tried to combine the triangles. And the problem is I'm still using 9 sticks. I didn't figure out a way to, in a 2D version, make the matchstick problem work. Now, the solution, as we can see here, is this. So we can see there's 1 triangle on the front, there's 1 triangle on this side, there's 1 triangle on this side, and 1 triangle on the bottom. So this makes sense. And then we have the overall prism. So a triangular prism is the answer to the matchstick problem. And these kind of little brain teasers, this is why those brain teasers are so problematic, is because they make us step outside of our box and use things in a different way. So we also have the candle mounting problem. So using these materials, so we have a box of matches, we have some thumbtacks, and we have a candle. Using these materials, how would we mount a candle on a bulletin board? So again, I'm going to give y'all a few minutes to see if you can think of a solution. Well, my fault. I've already shown you. So we'll just truck on. So this is again where you have to kind of think outside the box. So we have a bulletin board. Bulletin board is a flat object. We know that the function for thumbtacks is usually to pin things to the bulletin board. Now, we have a candle. Pinning that candle to the bulletin board using thumbtacks would not work very well. We'd have wax everywhere. We'd have to have a super long thumbtack. It wouldn't work. But if we think outside of the box, no pun intended, and take the matchbox and attach the matchbox to the bulletin board and then set the candle inside of it, we've solved the problem. So just different examples of ways that sometimes we have to think outside of the box to solve our problems. So all of these showcase creativity. So you've heard creativity usually in relation to art, music, something like that. So to be creative, you have to have three things. You have to have flexibility. So you have to be able to think outside of the box. You have to be able to think about things as having more than one use. So flexibility. Recombination. You have to be able to, in your brain, say, okay, how can I switch up the order of things to make something new? So being able to recombine things to make something different. And then insight. This is the sudden realization of a solution to a problem. This is your aha moment where suddenly you've been sitting around thinking, okay, how in the world does all of this thinking nonsense make sense? And then you go back through your notes, you recombine it in different ways, you try to think outside the box, and then suddenly you get it and the light bulb comes on. The insight part of creativity is the aha moment. It's the light bulb going off. It's when you finally put together all of the pieces of the puzzle. And then language. We're not going to spend a whole lot of time on language just because most of the activities I had for y'all involve being in class, and there's only a few questions on this on your test. So we're going to go through this pretty quickly. So the basic structure of language, this isn't just English, this is any language in the world. The basic structure of language is first a phoneme. So your phone makes noise, right? So in phonemes, it is the smallest distinctive sound unit in a spoken language. So I have an example down here. I have, when he was nearly 13, my brother Jim got his arm badly broken, at the elbow. So in this situation, I have WH underlined. Wh. That's one unit of sound. Th is another unit of sound. J and B. They all sound distinctly different, but they don't have any meaning on their own. If someone just walks up to you and says "buh," you're going to look at them like, okay, what's wrong with you? Because that carries no meaning. Morphemes, on the other hand, are the smallest distinctive units of sound that also carry meaning. Morphemes, meaning. Phonemes, phone, sound. Morphemes, meaning. So morphemes are also sometimes called stems. So a lot of times, especially in my class, we look at the stems of words to try to figure out what they mean. So we have examples like un, re, dis, and pro. Un means not. Re means again or over again. Dis means not, and pro means some type of forward. So morphemes can be put together to make larger words. This is what we typically do in the English language. Dark and ness. Dark by itself has a meaning, and ness means the state of. So the state of dark is darkness. Psych and ology. Psych means soul. Logy means study of. So the study of the soul is psychology, if you want to get philosophical. And then monotheism. Mono means one by itself. Theism means having to do with a god. So monotheism means one god. So those are morphemes. Syntax. Syntax is the rules that each language has for how you combine things to make proper sentences. So each language has its own set of rules. Each language has its own set of syntax. So in English, we put our adjectives before our nouns. We say white dog. We say green cup. We say orange shirt. In Spanish, for example, they put their nouns before their adjectives. I had to think about that for a second. So they put their nouns before their adjectives. So in Spanish, they would say shirt is orange, or they would say cup is green. So that's just the way that different languages structure things. And if you get into like French and German, and especially Arabic and some of those other foreign languages, they have different rules for how you make grammatically correct sentences. And then the structure of language. Semantics is, again, one of those philosophical deep terms that people think of. So I have my little, my Bitmoji is doing the thinking pose. So semantics, when we talked about semantic memory in chapter 10, we talked about it as the memory of like the rules of language. So semantics in language is the set of rules by which we derive meaning from morphemes, words, and sentences in a given language. Basically, that is a super fancy way of saying semantics is studying the meaning in language. So this is what you do in English class. In English class, when you break down a story, when you break down a play, when you talk about grammar, you're participating in semantics. You're analyzing the study of language. Okay. And that, my friends, is the end of your Unit 4 notes. We have made it to the finish line. It is over. So your test is going to be on Thursday, April 9th. It is in a Google form. This Google form is going to be on locked mode, meaning that once you start the test, you can't click off of it until you've submitted. If you click off of it, it's going to mark it as a 0. And if you try to reopen it again, it's going to send me an email saying that, hey, they tried to reopen this quiz. So what that means from my end is that you closed out the quiz or you closed out the test so that you could go find the answer and then come back to it. Don't do that. I expect y'all to have the same type of honesty that you would have in our classroom. So test is Thursday, April 9th. It will be posted at 8 a.m. and it will be available until 3:45 p.m. Guys, do not forget to do this test. Please make sure you have it done by 3:45. I'll send out reminds. I'll send out emails. I'll post on Classroom. Please make sure you do your tests in a timely manner. If you have any questions, I will be on Google Meet on, I think that's Tuesday, 4/6. That might be Monday. April 6th, starting at 2:30, I will be on Google Meet. I'll be available to answer any and all questions about anything related to this unit, related to the GIM kit, related to how e-learning is going to work in the coming days. I am here for you guys. I love you so much. If you need anything, do not hesitate to reach out. All right. Bye.